I think the aircraft research is very important because right now we know there have been some plane crashes like TWA 800, Swissair 111, because of faults on wires, intermittent faults. There also is a huge maintenance burden. The Navy says they spend 7.3 hours repairing their wires for every hour that they fly. And that's a lot. That's very expensive.
Yeah.
And you'd really rather that maintenance expense get to go to something that has the biggest, something else, like engines. You'd rather not have to waste it on wires. So if instead you could come up with a better way of locating these faults, you could reduce the amount of maintenance hours on wires and put it someplace else. So by developing this system, I think that's going to make a big impact both on safety and on economics in the aircraft industry. And that's important to all of us, really, if anybody travels. Then another piece of research that I feel very good about was my PhD research, where we analyzed the safety of cell phones next to the human head. It's pretty hard to say if something is safe or dangerous. It's hard to prove that something's safe. You certainly can prove it's dangerous, but if you come to the point where we're pretty darn sure it's safe, you don't really know how to prove it's safe. So that was the engineering job. The thing that we most wanted to do was be able to see if an individual cell phone met the guideline for how much power can be deposited in the head. And there are two ways of doing that. One is measurement and one is simulation, and my PhD was doing the simulation. The techniques that we developed during that PhD are still used today to be able to simulate cellular telephones and determine if the new models meet the safety guidelines. And that's a really important thing. So I feel that's been a major impact. The implantable antennas, I hope, only impact a small portion of the world. Only people who are have pacemakers or other implantable devices. Generally, they have something quite serious that needs to be handled with an implant, and you'd like to make that implant as efficient and as effective as possible. In the future, it's hoped that these implants will be able to do things such as stimulate nerves, to be able to move muscles or limbs, or to help people see or hear, and you need a way of communicating with those devices. So the implantable antennas can certainly have an impact there. With the small satellites, it's much, much cheaper to put up a small satellite than a big satellite. Sometimes you can just put them up on small rockets instead of having to go up on the space shuttle manned space vehicles. So being able to enable those small satellites is a good thing for both science and communication and security as well. So that's also a good project. The MIMO project, the Multiple Antennas project, I haven't really identified the application for that that's going to be most impactful. The ones that we're looking at right now is being able to communicate within an aircraft with the different sensors that are there, one of which, of course, is our wiring sensor, but some of which may be for vibration or temperature or heat or smoke detectors, and being able to communicate wirelessly better within the airplane and still safely. That's one. Probably the application that will end up being the biggest there is the personal communication systems. So better cell phone coverage. Still a good application.
Oh, that's really nice and interesting.